You've made it! This is the last part in my mini-series for feedback for each loops. In this video, I take all the things we've learned from basic concepts 1 through 4 and apply it to a practical use case by procedurally modeling a bookshelf. Now we're going to move on to the last basic concept, and this is going to use the feedback for each loop to model a bookshelf. Probably the most practical use of the entire feedback for each loop. This would be basic concept 5, and we're going to reuse this knife cutting. But I'm going to sort of do a reset, and I'm going to get rid of everything that I don't want. And the reason why I'm not starting from scratch is that I want to show you that this same concept can be used in so many different ways. So we're going to get rid of all this. We're going to get rid of this. Move this back up to save some real estate so I can zoom in. And we don't need that large number of iterations as well. So for the iterations, I'm gonna move it back to like, we'll start off slow and have 4. And now we need to modify the way that the knife cuts. For this example, I'm not going to be needing the kickstart initial state. So that will not be needed to make the bookshelf. So I'm going to get rid of the group. We won't need this origin as well, and these expressions won't make sense for the bookshelf. So I'm going to reset these and reset the origin to 0, the direction to a distance back to 0. So this is all reset. I won't need this create groups either. Now it's cutting right in the middle right now. And what I will need to do is we're not going to be cutting the grid in the X direction. And instead, we're going to be cutting the direction is upwards. So instead of 0 here, we're going to put 1 for the Y direction because we're going to go upwards now. And what that will result in cutting is we're going to be starting off here on the bottom. And we're going to go upwards. And this will be in the positive Y direction. And what this will result in is cutting the book shelves, the actual shelves, to cut out that in multiple cuts. So we'll have shelves on each level. Now before we begin, we need 2 things. We need to figure out the origin of the knife to tell the knife where to start, and the distance for each bookshelf. I'm going to create a null, and I'm going to keep all my data in this null, and I'm going to call it parameters. I'm going to pop this up. And I'm going to put some parameters in here first. So what do we need? We need the distance of each shelf, the height of each shelf, the individual shelves height, and the number of shelves. So that would be an integer. So this would be the number of shelves. Number of shelves. The next one would be the shelf height, or the height of shelves. And I would also need the height of the entire bookshelf, or the height of our grid, to be more exact. Okay, and so we have all our parameters in here, and let me close that off. Now let's fill this all in. The number of shelves, well, that will depend on the number of cuts we put in, and the number of cuts depends on the number of iterations of the for each loop. So for each loop here, so we're going to come over to the shelves over here, and we're going to copy this parameter and link it to the for each loop and number of iterations. So we can drive the number of cuts and control the number of shelves on our bookshelf. Let's come over here, right click, copy parameter, come to the number of iterations and paste relative references. So it dynamically links it. You change one number, it changes the other. And right now it's 0. But if I increase this number, it's going to change. 1, 2, 3, 4. This is incredibly useful because we have everything in one place over here. The next thing we want is the height. The height of the shelves. Well, how do we actually get the height of the shelves? Before we fill this in, let's actually fill in the other one first. The bookshelf height. Now, how do we actually get the bookshelf height? Let's pull this up, and I'm going to put, just for good practice, I'm going to put in a null here. I'm going to label this bookshelf shape. And in the bookshelf height, I'm going to put a bbox function. And this will get me the dimensions of a certain geometry at a certain node. And the node that we want is, again, just like a file system, ... means go up one level or anything other than this current parameters node. It's sort of like your file system go up one level in the folder system. And then we want the bookshelf. You'll see that it'll automatically fill you in. It'll automatically tell you, okay, we recognize this, the book part, and this is the only matching node that I find. So we can double click this, close it off with double quotations. The next thing we want is the d_y size, because I'm looking for the height, the size of the entire height of this grid. Enter it in. We're getting 0. That's because I forgot to align this grid in the correct alignment. So right now the grid is aligned in the ZX plane. So what we want is the XY plane. So it goes up and down. So you can see now that our bookshelf will not be lying on the ground. It will be standing up. My apologies. This was never connected. So that explains why this is still 0. Let's connect this. Let's make sure it's connected. The bookshelf has a height of 10. Now let's fill in the height of the shelf. The height of the shelves. Well, what will the height of the shelves be? It'll be the number of cuts. We're going to take this bookshelf here and we're going to apply the knife multiple times. The shelf height will be the height of this, and then say we're doing 3 cuts. 2, and coincidentally the last cut will land right at the bottom and you won't see it land exactly on the bottom line. This will give us the height of the shelf. Ignore the disproportional annotations I've done. Pretend this is exactly 1/3 each. Each section is 1/3. How do we actually get the height of this? So we need to figure out what the height of this. Well, we take the bookshelf height, the entire height of the bookshelf, and just divide it by 3 because it'll always be 1/3. The bookshelf only has even number of shelf heights. So this makes it a lot easier than it was before. So I'm going to take the bookshelf height and I'm going to copy this parameter. I'm going to paste it in here. Paste relative references because we want everything to be dynamically linked. Now I'm going to divide it by, but what am I going to divide it by? The number of shelves. So I'm going to take this number here and copy that parameter and paste it in here. Paste relative references again. So now we have the shelf height. And now we have enough information to continue on. Let's go into our feedback for each loop. Go into the knife. Let's fill in the origin. This should be the most simplest one. This should be a lot simpler than it was before. But I'm going to make this even more simpler because I'm going to put the grid exactly on the ground plane. So it starts off in the origin space. And in order to do that, let's use that same match size trick I did before. Just match the grid without having the second input empty. So it matches the grid axes, the world axes. I'm going to move the Y to the minimum, and that will land the grid exactly on the ground plane. This just makes our life easier. So we don't have to deal with the negative coordinates. Now, going back to the knife, so now we don't have to worry about the origin. It's already on the origin. Perfect. Let's go to the distance. Now, what would the distance be? I'm always cutting, I'm trying to cut out the shell. So when we're starting here, this is our starting origin. That's our origin line. And we're going to go upwards, the Y direction. So we're going to go upwards in the Y direction. What we should end up with, cutting in lines like this. Again, those are supposed to be straight. Okay, something like this. It should be cutting the shelves out like this. So we had to figure out the distance. We actually already know the distance because we already know the shelf height. We've already figured that out. So let's copy the shelf height, copy parameter, come over to the distance and paste it in here. Paste relative references. Okay, so now we have the first shelf. I don't know if you can see this line right here. We have that first line being cut. Let me turn on the points. So now we have that first line being cut right there. But that doesn't help us because if you've noticed that our feedback for each loop is 4. So we should have at least 4 shelves. We're only getting 1 cut right here. And that's because the knife is only cutting in a fixed distance. It's always cutting in the same spot 4 times. Let's go back to the knife. So now we need to adjust this distance value, and we need to have it iterate along with the for loop. As the for loop iterates, we need this distance to increase. And if you come over here, this node is sort of like the metadata of the for each loop. It holds all the information of a for each loop in the details. So if we go over here to the geometry spreadsheet, you'll see that we have a lot of different data here. We have the iterations, we have the iteration, which is the current iteration, the current cycle that the for each loop is on. Now it is 0 index based, so it is 3, meaning it's actually 4. Because it starts off with 0 and it counts 0, 1, 2, 3. The fourth one is 3. So you have to get used to that 0 index base. And this is super useful. We can access that data using that detail Houdini expression function. So let's go back to that knife. And in here, the distance, since we have that distance, we're cutting 2.5 distance every single time. So the second iteration we cut will be 5. Will be 2.5 times 2, which is actually 5. And the line will end up over here. It'll be 1 up. It will be 1 unit upwards. In order to get that, we're going to multiply this distance to the iteration number. So that would be perfect. Let's type in detail to actually access the iteration. And the first parameter would be which node to find that detail information. So let's go that, or double quotes again, and dot is that file system again, go 1 above this node. It's not in this current node for sure. So go 1 above, and what's the name of it? Well, the name of it is right here. It's this for each underscore count 1. That's the name of the node. That's exactly what we need up there. Let's fill this in for each, and you'll see that it automatically brings it up. This is the one we want for each underscore count 1. So let's double click that, close it up with quotations. And the next parameter we need is the name of the detailed attribute. What was the name of it? Well, let's take a look. Let's go back to that. Let's highlight this for each count, and let's actually look in the spreadsheet. And the name of it is iteration. So that's the name that we need. Let's go back to the knife and let's fill in the rest of it. So we know the name is iteration. Close it up, and it's a scalar value, so we only have one component, so 0 is the index. Let's close this up and enter. You can see that it's successfully cutting our shelves out of this grid. Now, this all works out because we can get the current iteration number from this node in the details attribute over here. This is where we get the current iteration number that feeds it into the knife so we know where to cut the shelves. Now, what happens if we accidentally deleted this node? So I take this node and I accidentally delete it. How do we actually get that back? It's actually very simple. Select the begin node for each block. So that would be the one that usually be the one that receives the input, the one that is labeled begin for each begin. So select that, and there is a button up here, a create meta import node button. Click that, and we'll get our metadata with all the iteration information. So we'll get all that information back, all that good stuff. So if you ever run into that problem where you accidentally deleted this node, that's how you get it back. But be aware, once you put it back, you can see that the name has changed from what I had before. So it's giving us an error in the knife over here. So you will have to update your details. We will have to update this name over here. It's no longer called for each count. It's now we have to update it to for each begin metadata to this name over here. Now, once we do that here, that warning should go away, or that error should go away. So indeed it goes away. Now I'm just going to undo this. Now, how can we actually turn this into a bookshelf? So that is how we can retopologize the geometry in a way that this will help us set us up for the bookshelf. The rest of this example will be more of a procedural modeling to complete this. So let me take all these squares or all these primitives, and I'm going to separate them. So we can do that using a facet node. And what the facet node does, it will unweld the primitives. As long as you enable this unique points, if we come over here and I take a primitive here and I move it, you can see that it's not welded anymore. It's not attached to the original geometry. As opposed, let's go before the weld, move it. It's actually attached when we move it. So it's welded on. Now back to here. After we detached every single primitive value, we can add a poly extrude, and we're going to start to see the shape of the bookshelf. I'm going to inset it first because I need a thickness around each shelf for the casing. So the inset is perfect for this. Now I can extrude out the sides. So poly extrude does something very handy for us. It will assign groups for every single part of that it extrudes out, and I want the side of it. So let me enable the output side and naming. So extrude side, let me copy this. I'm going to feed that group into our second poly extrude. I'm going to extrude this out, but this is extruding everything right here, as you can see. I'm only going to extrude a certain group, and that's the group that we inputted here, the extrude side. Let's plug it in here, and you can instantly see it only extrudes the side of it. To best illustrate this, let's go back to the poly extrude over here, and I'm going to put down a group. And I want to illustrate what part it's actually extruding. I'll take this. Now this is just for visual purposes. Extrude side. So this is what it's assigning to the group, all the sides that we have insetted. And then we're going to use all these sides and extrude it out to create the bookshelf shape. Once you have that in, you can really start to see the shape of the bookshelf already being formed, except for the back side. Don't look at the back yet. We can fix the back very easily. I'm going to take this original shape. This will be our original back of the bookshelf. Let me get rid of the lines. Back of the bookshelf. I'm going to reverse these. So it's facing the other way. Now I'm going to put a poly extrude. This is a very simple poly extrude. It's just extruding straight. Take this, extrude it out, and that will be the back side of our bookshelf. Remember not to have this out here. So the output back needs to stay disabled. You need to have this disabled, so otherwise you'll end up with a side inside the bookshelf, which is fine because it's being covered up, but it's not the best thing in the world. You don't want another unnecessary face within the bookshelf nested inside of it. Once I merge this together, I think you'll start to see what I mean. So I'm going to merge backside. Let me actually label this. And this is the front. So we're going to merge both of these together. And this is our bookshelf. This was only made possible because we laid down the groundwork using the feedback for each loop to create nice geometry or nice topology, to get it in the right topology first. And then it made life a lot easier over here after we had the right topology to extrude a few sides, and then we got our bookshelf. If we didn't have this initial shape to begin with, it would make life a lot harder. Now let's take a look at all this. And I'm going to move this down. Everything that happens in between, right after the for loop, here. Now let me template the entire bookshelf. Everything that happens in between here in this area modifies the entire bookshelf. This here up here is lays down the groundwork. As I said, it creates the basic topology that makes our life a lot easier, but it also creates sort of a face. This is sort of like the foundations of our bookshelf. However, we can add modifications right in here, and this sort of extrudes the shape of the bookshelf. Whatever happens, whatever we modify here will instantly affect the bookshelf. So we can put our own sauce or custom flavor in here. And to really illustrate that, I'm going to drop down an edit node right down here, right in the middle, right after the for loop, and watch what happens. Select the edit node, hover the mouse over the viewport, press enter. Now pick this little mouse cursor over here, and we're going to select the points because I'm going to be modifying the points. And then what we can do is click one of these guys, then press T. So that will bring up this little widget, this moving widget, which will allow us to modify the position of these points. We take our groundwork and we can enhance it or modify it. I'm just going to modify a few points. Press T again, drag it out, select the mouse, T again, drag it out. I don't know if some of you have seen some of those small house building shows. They always have these weird bookshelves right under a really, really small hole under the staircase, and they have this weird bookshelf in the shape, trying to make use of every little space under the staircase, under the stairwell, or it could be under the bed or under some sort of structure of the room. So let's take a look what the bookshelf looks like. We instantly have a nice little tool, bookshelf tool here. This could be an asset, because whatever we modify in here, all our custom modifications can be put in here. We can add our little sauce down here. And the rest of our tool, if we ever turn this into an HDA asset, it could be a bookshelf generator, it would automatically create the rest of the bookshelf for us. And don't forget, we've already parameterized the number of shelves. So we actually can change the number of shelves over here. We can change it to up 5, 6, 7, 8. Now keep in mind, our modification in this edit only affects the matching point number. So if we do change the number of shelves using here, we will have to update our edit. And this is one use case. I actually took this concept and went a little further up. Instead of manual edits, I managed to get a whole sine wave going on. So this is the manual edit one. But here I took the edges and actually applied a sine wave to get a really weird looking bookshelf now. And I took this even further and actually applied the sine wave to the actual shelf, which looks like this. This wavy shelf actually uses another for loop nested after the for loop, like a chain of for loops, in order to get this going. Hopefully this will get your mind tingling, and after watching this video, you'll think of new and creative ways on how the for each loop will help you in your own projects. I've added some clips from some of my previous projects where I used the for each loop to help me with certain things while I was procedural modeling a construction platform in Houdini. Here you'll see I'm using the for each loop to iterate through each polyline and shrink the rail lengths. In the next connected for each loop, I adjust the rail length and size procedurally. The last example I have here is a window blinds where I use the for each loop to collapse the blinds. Each individual sheet of blind is moved up until it hits the next blind, so this isn't as simple as moving it up. Nor can a simple copy and transform do this either. Notice as the blinds are moved up, the number of blinds are different as well. This makes it possible to collapse the blinds dynamically without knowing a predetermined height. Thank you for watching and sticking to the end.